Welcome students, in this class we will be learning about orthogonal trajectories. Now the meaning, or whenever you see the word orthogonal, it means there is an intersection which is taking place at 90 degrees. Now trajectories means it is actually the mathematical equivalent for the word path. So we are talking about curves which are intersecting at 90 degrees. That is the simplest way to explain this topic. Now there are two different types of questions you will encounter in orthogonal trajectories. One is to obtain the relevant equation for the family of curves in Cartesian coordinates, and the other is to obtain it in polar coordinates. So we will be handling these two questions, or these two types. So having mentioned that, trajectory of the following curve, x squared positive y squared is equal to a squared. So what exactly they are asking us? Now just imagine that you have a curve which is moving like this, and this is given, right? Now what they are asking you is, they are asking you to find all the curves which are intersecting this curve. Now when they are saying a curve is moving like this, it means they are giving you a family of curves in this fashion. Okay, the family of curves might be looking like this. I'm just giving you an insinuation. Now what are you expected to do is, you are expected to find all those curves which can intersect the curve at 90 degrees. So this should be 90 degree intersection, this should be a 90 degree intersection. So wherever you can find an intersection, that intersection should take place at 90 degrees. That is the requirement for this question. So they have given us x squared positive y squared is equal to a squared. Now what is this? This is nothing but a family of circles. Okay, the family of circles, and the value of a can start from 1 and it can go on. A can be equal to 1, a can be equal to 2, a can be equal to 3 and 4 and so on. Now for every time value that a takes, there is a family that is being produced, a family of circle. In other words, a circle is being produced for every value that a takes. And the circle is centered around the origin because of the fact x squared positive y squared, right? So it is centered around the origin, but the only difference here is the radius changes. Have that in mind, the radius changes. So we have something of this fashion, and we are expected to find those families of curves that will intersect the given family of curves at 90 degrees. So that is the explanation, or the best way to understand. So how are we going to handle this question? The first point that you need to do is to differentiate. So when you differentiate, what are you trying to do? You're getting rid of the constant. So differentiating with respect to x, that is the simplest fact. Now you got one arbitrary constant, so your differentiation should be for 1. If you got two arbitrary constants, so you have to perform the differentiation twice. So differentiation of x squared will give you 2x, differentiation of y squared will give you 2 times y, dy over dx is equal to 0. From here I can say 2 times y dy over dx is equal to negative 2 times x. The 2 and 2 can be cancelled, so I get dy over dx is equal to negative x over y. So this is what I've got. Now this is the first step. Now the second step is to obtain that equation for those families of curves. You will have to replace dy over dx by negative 1 over dy over dx. This is the replacement that you will have to do, or I should say the substitution. This is the very important substitution. This is step number 2. So if I were to take this as say 2, and this to be as 1, and this to be as 3, so using 3 in 2 we get, so dy over dx, in place of dy over dx I'm going to use negative 1 over dy over dx, which is equal to negative x over y. Of course the two negatives will become positive, so now I can flip this. When I flip it, I get dx over dy is equal to x over y, and this can be solved using variable separable. So I get a dx divided by x is equal to dy divided by y, and if I were to obtain the integration, then this is going to give me ln x and this is going to give me ln y. Of course, there is an arbitrary constant c. Now what I will do is, you can either place it as c or you can place it as ln c. It doesn't matter. So if I were to bring this ln y to the left, you are going to get ln x negative ln y is equal to ln c. Of course, this is going to be ln of x over y is equal to ln c. And excuse me, if you are not interested to further simplify, you can leave it here, but the usual way is we will proceed on to the simplification. So removing log both sides, so we get removing ln. When I say log, it means ln both sides. So what do you get when you remove that? So you get x over y is equal to c. Now what I wish to do is, I would like to rewrite this as for y. So that means I will bring that c down. X over c is equal to y. Now I got y is equal to x over c. Okay, x over c. Now this c, I can rewrite it as x times 1 over c, something of this fashion. And I can replace 1 over c by some arbitrary constant m. So I now get y is equal to mx. Now what is this? For each value, or I would say for any values that m take, we are getting a family of straight lines. You follow me? We're getting a family of straight lines for different values of m. So m can take 1, m can take 2, and m can take 3, and so on and so forth. So this is the family of curves that is required. In other words, this family of curve is actually intersecting the given curve orthogonally. That is the understanding. So if we have to visualize, how does the visualization go? So in the previous case, I have just shown you this. So this is how the family of curves that are being given. Now this is x squared positive y squared is equal to a squared. So a family of circles. Now we get y is equal to mx, or I would say, okay, that's just y is equal to mx. Now for different values of m, you get a straight line like this. Okay, you get a straight line like this. You can get a straight line like this. You can get a straight line that is moving on like this. You can get a straight line that is moving on like this. So you can find that there are many straight lines that are being obtained for various values of m. So m is equal to 1, m is equal to 2, m is equal to 3, m is equal to 4, so on and so forth. Now the most important point you will have to observe here is, for any place or any intersection that you see here, that intersection will take place at 90 degrees. So there is an intersection here, it's 90. There is an intersection, it will take place at 90. This intersection will be at 90. This intersection will be at 90. So the idea is, we are looking for two set of curves which are intersecting each other at 90 degrees. So that is the reason the name has come up as orthogonal trajectories. Now there are many applications to this particular concept in mathematics, because it is not easy to obtain an intersection of two sets of families at exactly at 90 degrees, right? So mathematically, using differential equations, you can exactly obtain those families of curves where you can show it in accuracy. This is the family that is intersecting the given family orthogonally. So that is the first question. We will try to push on and move on to other questions. Students, we are expected to find the orthogonal trajectories of the following family of curve: x raised to the power of 2 over 3 positive y raised to the power of 2 over 3 is equal to a raised to the power of 2 over 3, where a is an arbitrary constant. So this is the family of curves that are being given. So first number, or I should say step number 1, let me write this down: x raised to the power of 2 over 3 positive y raised to the power of 2 over 3 is equal to a raised to the power of 2 over 3. This has got one arbitrary constant. So we will have to differentiate this with respect to x both sides once. So differentiation of x raised to the power of 2 over 3 is going to be 2 over 3 times x raised to the power of 2 over 3 negative 1. Positive y raised to the power of 2 over 3 is 2 over 3 times y raised to the power of 2 over 3 negative 1 times the differentiation of y is dy y over dx. A raised to the power of 2 over 3 gives me 0. I can rewrite this as 2 over 3 times y raised to the power of 2 over 3 minus 1. This is going to give me negative 1 over 3, which is, of course, there's a dy over dx. And I'm going to push this to the other side. So that's going to be negative 2 over 3 x raised to the power of negative 1 over 3. Now, I got a 2 over 3 and I 2 over 3. Both of them can be cancelled. So now what I've got dy over dx on the left hand side. Now, you got a negative sign here. Now I can actually push this x raised to the power of 1 over 3 down. So that's going to be a positive value there. Now I already get a y raised to the power of negative 1 over 3. So if I were to bring this down, this is going to be in the denominator, but it's got a negative exponent, right? So I can push it to the numerator. So that's going to be y raised to the power of 1 over 3. So this can be rewritten as negative y raised to the power of 1 over 3 divided by x raised to the power of 1 over 3. So this is what I've got for dy over dx. Now step number 2, what are we to do? We have to replace dy over dx by negative 1 over dy over dx. This is the replacement we'll have to do. So what I will do is I will take this as 3. I'm going to take this as 2, probably the given system as 1. So we can simply state that using 3 into we get. So dy over dx is negative 1 over dy over dx is equal to negative y raised to the power of 1 over 3 divided by x raised to the power of 1 over 3. Now these two will become positive. I can flip this. So if I were to flip it, I would get dx over dy is equal to y raised to the power of 1 over 3 divided by x raised to the power of 1 over 3. Now I can just use variable separable. So this will go to the x side and this will go towards the right side. So if I were to rewrite this, so let me use this particular space. Let me use a space on this side. So I've got x raised to the power of 1 over 3 times dx is equal to y raised to the power of 1 over 3 times dy. This is what I've got. So now, just for sake of consistency, I want to rewrite it like this. Y raised to the power of 1 over 3 times dy is equal to x raised to the power of 1 over 3 times dx, and then I'll integrate it. So if I were to integrate this, this will give me y raised to the power of 1 over 3 positive 1 divided by 1 over 3 positive 1 is equal to x raised to the power of 1 over 3 positive 1, 1 over 3 positive 1. Of course, there is a constant, so I can place that. This is going to give me x raised to the power 1 over 3 and you get a 3 there. So that means you get 4 over 3 divided by 4 over 3. And then you have a constant there. And then this is y raised to the power of 4 over 3 and you get a 4 over 3. So what you can do, you can multiply by 4 over 3 throughout. So if you were to do that, so that would mean you get y raised to the power of 4 over 3 is equal to x raised to the power of 4 over 3 positive 4 over 3 times c. Now what I can do is, of course, I can push this to the other end and I can bring this y. Now depends on what you want, right? Depends on what you want. Most of the times they will have a positive sign for the x. So I would follow the same thing just for the sake of consistency. And I will move this 4 over 3 times c to the other side. So this is going to become negative 4 over 3 times c, and this is going to be x raised to the power of 4 over 3 with y coming to this side. So it's going to be y raised to the power of 4 over 3. So this entire thing can be replaced as a constant. So I'm going to rewrite this entire thing as x raised to the power of 4 over 3 negative y raised to the power of 4 over 3 is equal to some constant, capital C. So this is the final solution. Now what is this? This is what we want. Those families of curves that are intersecting the given family of curves in an orthogonal fashion or orthogonally. So that completes the solution to this question. Students, we will move on to the next question. Students, we are given this question: find the orthogonal trajectories of the family of curves given by y squared is equal to c times x to the power of 3. Of course, c is the arbitrary constant. Start off by writing the question. The question given to us is y squared is equal to c times x to the power of 3. Now we will perform the first step, which is differentiating the given question with reference to x both sides. So if I were to do that, this is going to give me 2 times y raised to the power of 2 negative 1 times dy over dx is equal to 3 times x squared times c. I can further rewrite this as 2 times y dy over dx is equal to 3 times x squared times c. Now c is the arbitrary constant, so we will have to get rid of this c. So how are we going to get rid of this c? I'm going to take this as 1. Now from 1 we can see that. So what can we see? We have got y squared is equal to c times x to the power of 3. Therefore c is y squared divided by x to the power of 3. So if I were to take this as 2, I'm going to write that, using c is equal to y squared over x to the power of 3 into, we get, so what do we get? You got 2y times dy over dx is equal to 3 times x squared. In place of c, this is going to be y squared over x to the power of 3. I can rewrite this as 3 times x squared and x squared can be cancelled, giving me 3y squared divided by x. Now this is 2 times y dy over dx. So let me extract dy over dx from here. So therefore dy over dx is equal to, you get a 3y squared over x is there, you're bringing 2y down, so it's going to be 2 times y and x. I can cancel a y here, so this is going to be 3 times y over 2 times the x. So this is stage 1, right, or step 1. So I have executed step 1 here. Now step 2, what is step 2? Step 2 is take dy over dx to be as negative 1 over dy over dx. Now if I were to take this as 3, or probably, okay, 3, so therefore 3 can be rewritten as, in place of dy over dx, I get negative 1 over dy over dx is equal to 3 times y over 2 times x. So if I were to flip this, this is going to be dx over dy is equal to, I'm going to place the negative sign here, so 3 over 2 times y over x. By using variable separable technique, I can rewrite this as x times dx is equal to y times dy. Of course we have to be concerned about the 2 and the 3, so I can place a 3 here with a negative sign and a 2 here, so I can integrate both sides. So if I were to integrate this, this is going to give me 2 times x squared over 2. If I were to integrate this, this is going to give me 3 times y squared over 2. Of course I get a positive arbitrary constant c. Now the 2 and the 2 can be cancelled here. So if I were to cancel it, and then probably I have a quantity of this fashion. So let me just write this down. So I'm going to move this y squared to the other side. So it's going to be 3 over 2 times y squared positive x squared is equal to arbitrary constant c. Now if you don't want anything to be with y, then you will have to multiply every quantity by 2 over 3 throughout. So if you were to do that, this is going to be y squared positive 2 and 3 gets cancelled here, so this is going to be 2 over 3 times x squared is equal to 2 over 3 times c. Now This is an arbitrary constant, so we can replace it as y squared. So we can rewrite this entire system as y squared positive 2 over 3 times x squared is equal to some arbitrary constant capital C. So this is the solution. Either you can replace the solution like this, or you can start with x term. So 2 over 3 times x squared positive y squared is equal to C. So this is a good place for us to stop. Probably I will place a line there. Students, we are given this question. Find the orthogonal trajectories of the family. The curve is y is equal to c times x and c is arbitrary constant. So let me just write that down. So this is given. So this is our first step. In the first step we write the question down. So y is equal to c times x, and then we will differentiate with respect to x both sides. So when we do that, we get dy over dx is equal to c times x is, the differentiation of x is 1. So we get dy over dx is equal to c, but we will have to get rid of the c. Now I'm going to take this as 1. So from 1, so what do we see from 1? We got y over x is equal to c, right? So using this in 2, so I'm going to take this as 2. So we get, so what do we get if we were to use this in 2? So dy over dx is equal to, in place of c, we get y over x. So this is what we have got. Now step 2, what is step 2? In step 2, we will have to replace dy over dx as negative 1 over dy over dx. So if I were to take this as 3, therefore my 3 can be rewritten as negative 1 over dy over dx is equal to y over x. So if I were to flip this, this is going to give me dx over dy. I'm going to place the negative sign on the right side, so it's going to be negative y over x. So this is what we're going to have. So using variable separable, I can move this and this in this fashion. So this is going to give me x times dx is equal to y times dy with a negative sign. So I would be integrating both sides. So if I were to integrate, this is going to give me x squared over 2. This is going to give me negative y squared over 2, positive arbitrary constant c, which can be rewritten as x squared over 2 positive y squared over 2 is equal to some c. I will have to multiply by 2 throughout. I don't want this 2 in the denominator. So this is going to give me x squared positive y squared is equal to 2 times some c. I want to replace this c by some other arbitrary constant. So I can rewrite it as x squared positive y squared is equal to some a. So this is a beautiful solution. So this is the family of curves that are functioning as an orthogonal trajectory for the given family of curves y is equal to cx. So one is a circle, the other is a straight line. So we'll move on to the next question. Since we are given this question, we are expected to find the orthogonal trajectories for the given family y is equal to c over x. Now this is a special type of hyperbola. I hope you all know this. So let us get started. So step number 1, we will just write the question y is equal to c over x. Then I will perform the differentiation with respect to x. So if I were to do this, this is going to be dy over dx is equal to differential of 1 over x. So this is going to be negative c over x squared, right? Because x is in the denominator. Now if I were to take this as 1, from 1 I can rewrite 1 as, I want to get rid of the c, so I will have to write a representation for c. So c is equal to x times y. Now using this, I'm going to rewrite 2. Therefore 2 can be rewritten as dy over dx is equal to negative x times y divided by x squared, which is equal to y over x with a negative sign. So step 1 is finished. So coming to step 2, what do? We take dy over dx to be as negative 1 over dy over dx. So this is a substitution that we will follow. Now if I were to take this as 3, so therefore I can rewrite 3 as, in place of dy over dx is going to be negative 1 over dy over dx is equal to negative y over x. So this will become positive. I can flip and rewrite it as dx over dy is equal to y over x. I can move them by variable separable technique. So this is going to be x times dx is equal to y times dy. So if I were to integrate this, this would give me x squared over 2 is equal to y squared over 2 positive arbitrary constant c. Now what we can do is we can bring everything to the left hand side. So I'm going to place the output here. So this is x squared over 2 negative y squared over 2 is equal to constant c. So now I'm going to multiply by 2 both sides. So if I were to do this, this is going to give me x squared negative y squared is equal to 2 times c. Now I can replace this 2 times c as some capital arbitrary constant c. So on the left hand side I get x squared negative y squared. What is this? This is actually an hyperbola, right? We have studied this. So if you were to picturize this, how are you going to picturize this? Say this is the x-axis. Let me draw the x-axis, and this is the y-axis. So we have given y is equal to c over x. So that hyperbola will be of this fashion. Okay, this is how it will be. Okay. Now we have x squared negative y squared. So how that would be? That would start like this, start like this, like this, like this. Okay. So this is a beautiful question, and I hope you are able to visualize this. So thank you, students. We will move on to the next topic. Students, we have got this question. Let me write the question down. We are expected to form or find the family of curves that are orthogonal trajectories to the family x squared positive y squared negative 2 times c times x is equal to 0, where c is the arbitrary constant. Okay. So this is the question that has been given. So as usual, what I will do is I will start with step 1. Step 1 is I will write x squared positive y squared negative 2 times c times x is equal to 0, and then I will differentiate the terms with respect to x both sides, and that would give me 2 times x positive 2 times y dy over dx negative 2 times c is equal to 0. Now I should eliminate this arbitrary constant c. So I'm going to rewrite this as 2 times x positive 2 times y dy over dx is equal to 2 times c. I can cancel the 2 and then rewrite this as x positive y times dy over dx is equal to c. Now I'm going to take this as 1. What I would like to do is using, if I were to take this as 2, using 2 in 1. So in place of c, I'm going to substitute this in this system. So we get, so what do we get? This is x squared positive y squared negative 2 times x positive y times dy over dx is equal to 0. So this is what we have got, and I can rewrite this as x squared positive y squared negative 2 times x squared negative 2 times x times y dy over dx. This is what I've got. X squared and negative 2x squared can be added, so this is going to give me negative x squared positive y squared negative 2 times xy dy over dx. So I'm going to push this to the other side, and this is going to give me 2 times xy dy over dx. Now this is my step 1. Now for my step 2, what I wish to do is I'm going to say let dy over dx is equal to negative 1 over dy over dx. So this is the substitution that I will have to make, and probably I will have to take this as say sum 3. So I'm going to take the substitution over here, and I need to have a space. Probably I will use this space over here. So what happens, 3 will now be rewritten as negative x squared positive y squared is equal to 2 times x times y times negative 1 over dy over dx. So I can actually flip this and bring everything down. So let me just flip this. So this is going to give me 2 times xy dx over dy. There is a negative sign there, so there is a negative x squared positive y squared. So this is what I have got. So now I will have to do some manipulations so that we can solve this. So this is our objective, so we will have to solve this. So I will have to move to the next page and then I will solve that. So this is what we've got. So what I would do is I would rewrite this as negative x squared positive y squared divided by negative 2 times xy is equal to dx over dy, and from here dy over dx is going to be negative 2 times xy divided by negative x squared positive y squared. Now I want to get rid of this negative sign here, so I'm going to take a negative sign out and rewrite this as x squared followed by negative y squared. So this is what I get, and I got a negative 2 times xy in the numerator. So this is fine. Negative times positive is negative, negative times negative is positive, so this one is going to be positive. So you got dy over dx is equal to 2 times xy divided by x squared negative y squared. Now you have to solve this. Now this is homogeneous equation, and so I will just say let y be equal to vx, and then dy over dx is equal to v positive x times dv over dx. So this is the substitution we know already. So in place of dy over dx, I will substitute v positive x times dv over dx. In place of y, it's v times x divided by x squared negative v squared x squared. This is 2 times v times x squared divided by x squared of 1 negative v squared. I can cancel the x squared out. So this is going to give me 2 times v of 1 negative v squared. And I can push this v, I get a negative v there. So it's going to be x times dv over dx. Now if I were to take the LCM, I get 1 negative v squared, 2v negative v of 1 negative v squared, which is 2 times v negative v. This is going to be a positive, negative negative positive, v times v squared. That's going to be v raised to the power of 3 divided by 1 negative v squared. So 2v and v, they can be taken summed up, so that's going to be v positive v cubed divided by 1 negative v squared. So I can take a v out, rewrite this as 1 positive v squared divided by 1 negative v squared. I have to just retain it as it is because I can't do anything as of now. So now I get dv on this side. So what I wish to do is I would be moving all the v towards the left hand side. So I would get 1 negative v squared divided by v of 1 positive v squared times dv is equal to dx divided by x. Now let me consider 1 negative v squared divided by v of 1 positive v squared. I have to use partial fraction, so I'm going to rewrite this as a over v positive bv positive c divided by 1 positive v squared. So if I were to multiply, I get a of 1 positive v squared positive bv positive c times of v. This is what I get. I need to simplify this, so I take v to be as 0. If I take v is equal to 0, then this would become 0, and I get A. This is 0 and this is 0, so I get A is equal to 1. That's fine. Now the next case is I have to take V squared is equal to 1, or V squared is equal to -1. So that would mean this will create an issue for me. If I were to take V squared is equal to -1, it will become a complex quantity. So I have to avoid that. So to avoid that, I will just take V is equal to 1. Now if I take V is equal to 1, this one will become 0. Right, so I got a 0 there. So this is going to be 2 times A. I will get a B positive C. Right, so B positive C, V is equal to 1. So A is already 1 here. So minus 2 times B positive C would be one system. So I will take V is equal to, say, some 2. So if I take V is equal to 2, this one is going to be 1 negative 2 squared is 4. So this is V is equal to 2, 4 positive 1, that's 5 times A, and this is 2B positive C. Now probably what we could have done is, even if I take V squared is equal to V is equal to -1, if I take V is equal to -1, there wouldn't be any harm here. So instead of complicating it with V is equal to 2, let me just show that to you. If I were to take V is equal to -1, so this one will still be equal to 0. Now V is equal to -1, so this is going to be 2 times A, and negative B positive C -1. That's going to be giving me A is 1, 2, positive, negative will become positive, and negative C is equal to 0. So negative 2 times B negative C. So I'm going to use here B negative C is equal to -2. So clearly my CC can be cancelled, giving me 2 times B is equal to -4. So therefore B is equal to -2. Right? So I get a B is equal to -2. I already get a A. So if B is equal to -2, if I were to take this as some 4, so I substitute -2, -2, and C. So C will be equal to 0. Because -2 positive 2 is equal to C, therefore C is 0. So that's fine. So I'm getting C is equal to 0. So if I were to take this as some 3, okay, so therefore I can write 3 as 1 negative V squared divided by C times of 1 positive V squared is equal to, my A is 1 over V positive, my B is -2 times V, my C is 0, divided by 1 positive V squared. So that's fine. So it all comes down to this. So I'm going to take this as 2. So what have we achieved? So therefore I can rewrite 2 using this. So that would mean 1 over V negative 2V over 1 positive V squared. This entire thing has to be multiplied with dV is equal to dx over x. So if I were to integrate this, this is dV over V negative 2 times, probably I can just place 2 inside. I should have done that. Never mind. So this is what you've got, dx over x. Now this is ln V. Now this is, I'm going to use a substitution here. Now 1 positive V squared is equal to some t. So 2V dV is dt. So I got 2V dV and I'm trying to integrate that. So in place of 2V dV, it's going to be dt, and in place of 1 positive V squared is t. So this is going to be ln t, but this is going, t is 1 positive V squared. Right, so I have a negative sign, so this is going to be ln of 1 positive V squared is equal to ln x, plus I can put a ln c. Now this is ln a minus ln b, so it's going to be ln of v divided by 1 positive v squared. I can rewrite this as ln of x times c, so ln can be cancelled, so v is equal to 1 positive v squared is equal to x times c, but y is equal to vx, so my v is y over x, so I substitute here. So let me use this space here. So this one is going to be y over x divided by 1 positive y over x raised to the power of 2 is x times c. This is y over x divided by 1 positive y squared over x squared is equal to x times c. Now this is y over x divided by x squared positive y squared divided by x squared. So I can actually, okay, I will flip it in the next. So this is x into c. So I'm going to use a space here. So if I were to flip it, this is y over x. I flip it, I get x squared over x squared positive y squared is equal to x times c. Now x and x gets cancelled. That is a x and a x can be cancelled. So this is going to be y over x squared positive y squared is equal to c. This is what we have got. Probably we can stop here, or if you want you can rewrite this as y is equal to c times x squared positive y squared. Right, so this is the solution. So this is the family of curves that is actually has an orthogonal trajectory with a given system. Now you have to do all of these. Now why you have to do all of this is this problem. I will just show you this. Now all happened because of two reasons. Instead of this x, you can try this out. If they have given you this x squared positive y squared negative 2 times cy is equal to 0, if they had given you this would be a cakewalk. Okay, if they had given you this, but they didn't give you that. They gave you negative 2 times c times x. So that is the reason the entire system got complicated. Alternatively, they will, if they don't want to take you on, instead of find the family of curves, they will say find the differential equation. That's all. Okay, instead of giving you the family of, asking you to find the family of curves, they will say find the differential equation. So that reduces the question's complexity in a greater manner. So thank you, students.